All right, let's go ahead and take a look at number 1 on our homework, 11.5. As we look, we've got, for number 1, chlorine gas is being collected by water displacement at a temperature of 19 degrees Celsius. Now, this water displacement means that chlorine is bubbling up through the water and collecting in that chamber, being vacated by the water as it is slowly pushed out to keep our pressure the same. Now, the total volume of our final chamber is 1.45 liters at a pressure of 1.54 atmospheres total. This is the total pressure. Now, assuming that all of the chlorine is in our chamber and that no chlorine gas is dissolved in the water, and then they tell us that the water vapor pressure, so the water at that particular temperature has its own pressure, pressure of just the water, of 0.02 atmospheres. Now, part A. Part A says calculate the pressure due just to the chlorine gas. Well, okay. In this particular case, we're interested in the pressure of just the chlorine. But there's another gas in there that we need to be concerned about. That other gas in there was the pressure of the water vapor. So what we're going to do is we're going to use the Dalton's law of partial pressure to figure out the pressure from just the chlorine. Now, if you remember, we said that the total pressure, P total, must equal the pressure of the water plus the pressure from the chlorine gas. These two added together must give us the total pressure. Well, they told us that the total pressure up here was 1.54 atmospheres. The pressure from the water at that particular temperature was 0.02 atmospheres. And they want us to figure out what the pressure is from just that chlorine. Well, now we've got to set it up. This just became a math problem straight up. To solve for the pressure of the chlorine, we're going to take and subtract both sides by the pressure of the water. What we do to one side, we must do to the other. Cancels from this side, so we now know that the pressure of the chlorine in that chamber is equal to 1.52 atmospheres. So the pressure being created from just the particles of chlorine is equal to 1.52 atmospheres for this particular problem. Now, part B says calculate the number of moles of chlorine gas that were produced. Well, wait a minute. We're trying to solve for the moles, moles being N. Well, what else do we know about this chlorine? We know the pressure from the last part is 1.52 atmospheres. We also know that it had a volume of 1.45 liters and it had a temperature of 19.0 degrees Celsius. Wait a minute. We've got pressure, volume, we're solving for moles, we got an R, and we've got a definite PV equals N. Oop, that's an M. N R T. PV equals nRT. P as in pressure. Well, the pressure of our chlorine, that's the part we're interested in, the chlorine. Pressure from our chlorine was 1.52 atmospheres. Atmospheres okay? Yep, atmospheres okay. Cool. We're going to take that times the volume. We've got 1.45 liters. Liters okay? Yep, liters is okay. 1.45 liters. That's going to equal the moles, which in this case we don't know. I'm just going to leave it as an N, times R, which was 0.08206 liters times atmospheres over mole Kelvin. Times our temperature in Kelvin. Wait a minute. Ooh, we're in Celsius. Oh, shoot. To get to Celsius, we take our, to get to Kelvin, we take our degrees Celsius, and we add 273. When we do this, we find we've got a final temperature in Kelvin of 292 Kelvin. Awesome. 292 K. Quick look at our units tells us we are on the right track. We've got atmospheres on the left, atmospheres on the right. We've got liters on the left, liters on the right. We've got Kelvin on top, Kelvin on bottom. Awesome. The only unit that doesn't cancel is moles. Now we just solve. Okay, go ahead and multiply the left side together. We get a value of 2.0. Excuse me. Sorry about that. 2.204. When you multiply those two guys together, that's going to equal N times this side multiplied together. 0.08206 times 292. When we multiply those together, you should get 23.96152. Well, to get N by itself, Right now it's being multiplied by a number. We do the opposite. We're going to divide both sides by that 23.96152. What we do to one side, we must do to the other. That's Math 101. 152. Cancels from this side. We find that n equals 2.204 divided by our 23. N equals 0.091980892, and that was moles. Oh, please tell me you were yelling at the screen. We need sig figs. Go back to the original problem. We had 3, 3, 4, 3. Looks like we're keeping 3. Our first 3 sig figs are here. 8 is going to go ahead and round the 9 up. That's going to bump up our 1. This is going to equal 0.0920 moles of chlorine gas produced. Number 2, you're going to find very similar. Number 3 might make you think a little bit, but I bet you and your partner are well on your way to solving these problems. Give this a shot. This is our homework for tomorrow.